हेलो एवरीवन। सो इस वीडियो में हम लोग गेट 2025 का क्वेश्चन नंबर 11 सॉल्व करेंगे। दिस जो क्वेश्चन पूछा गया था लीनियर अलजेब्रा से। सो क्वेश्चन नंबर 11 में हमें एक ऐसा इस सेट में कुछ ऐसा R3 का मेंबर होगा जिसको हम लोग इस कलम वेक्टर से अगर मल्टीप्लाई करेंगे तो जो मैट्रिक्स आएगा वो डायगोनलाइजेबल होगा एंड नॉर्म ऑफ W 1 होगा। सो पहले इसके लिए मैं क्या कर रहा हूँ, आई एम चूजिंग अ W बिलोंग्स टू S where W equal to W1, W2, W3. Okay, so now as W belongs to S, I can say that 1 minus 3 2 into W means W1, W2, W3 is a diagonalizable, right? So अगर हम लोग इस कलम वेक्टर को इस रो वेक्टर से मल्टीप्लाई करेंगे और अदरवाइज इन अदर वर्ड आई कैन से दैट इस कलम मैट्रिक्स को इस रो मैट्रिक्स से मल्टीप्लाई करेंगे तो हमें क्या मिलेगा, W1, W2, W3 minus 3W1 minus 3W2 minus 3W3 2W1 2W2 2W3. So this is a 3 by 3 order matrix. 3 by 3 order matrix. I am considering this matrix as to be A. Now, and with the condition that norm of W is equal to 1. Now, norm of W is equal to 1, that is representing W not equal to 0, 0, 0, right? W not equal to 0, 0, 0. Now, the point is that this matrix A is diagonalizable. चलो देखते हैं this matrix A कब diagonalizable होगा. So पहले देख लेते हैं मैट्रिक्स A के लिए. फॉर मैट्रिक्स A हम लोग देख सकते हैं कि A जो मैट्रिक्स है, this column and this column are actually same, just W into this column, W1 into this column, W2 into this column, W3 into this column. So in other word, I can say that A has only one linearly independent row, right? A independent column. It has only one linearly independent column. So therefore, A जो मैट्रिक्स होगा इसका रो रैंक जो होगा वो मैक्सिमम 1 होगा और मैट्रिक्स का रैंक रो रैंक से हमेशा छोटा होता है. सो इससे हम लोग बोल सकते हैं मैट्रिक्स जो है ए मैट्रिक्स का रैंक एग्जैक्टली 1 होगा. ठीक है. नाउ पॉइंट इज दैट एज मैट्रिक्स ए इज 1, सो हम लोग इससे क्या बोल सकते हैं, जो डेट ऑफ ए दिस इज इक्वल टू 0. नाउ हमें क्या पता है, फॉर एनी मैट्रिक्स, फॉर ए बी एन क्रॉस एन मैट्रिक्स, then date of A is equal to 0 if and only if 0 is an eigenvalue of A. ठीक है ना. सो डेट ऑफ ए 0 होगा तो ये जो मैट्रिक्स है उसका 0 एक आइगन वैल्यू होगा ना. नेक्स्ट, फॉर आई एम जस्ट राइटिंग अ डेफिनेशन, तुम लोगों को पता ही होगा, फॉर एनी आइगन वैल्यू lambda nullity of A minus lambda I is called geometric multiplicity of lambda, right? पता ही होगा. Or I am going to use another theory that any matrix is definitely a square matrix is diagonalizable if and only if algebraic multiplicity of eigenvalue equal to geometric multiplicity of eigenvalue, राइट। हर आइगन वैल्यू का एल्जेब्रिक मल्टीप्लिसिटी अगर जियोमेट्रिक मल्टीप्लिसिटी के साथ इक्वल होगा तो हम लोग बोल सकते हैं कि मैट्रिक्स डायगोनलाइजेबल होगा। नाउ पॉइंट इज दैट रैंक ऑफ ए इज इक्वल टू 1। सो बाय रैंक नलिटी थ्योरम हम लोग बोल सकते हैं नलिटी ऑफ ए व्हिच इज इक्वल टू 2। सो हम लोग बोल सकते हैं व्हिच इज इक्वल टू नलिटी ऑफ ए माइनस 0 आई, ठीक है ना। इससे हम लोग क्या बोल सकते हैं, इससे हम लोग बोल सकते हैं देयरफॉर geometric multiplicity of the eigenvalue geometric multiplicity of the eigenvalue is 2. Now point is that as geometric multiplicity of the eigenvalue is 2, so as this matrix is diagonalizable, so हम लोग इससे बोल सकते हैं therefore algebraic multiplicity of the eigenvalue 0 is also 2. Now as this is a 3 cross 3 matrix, so इसका 3 आइगन वैल्यू होगा, 2 आइगन वैल्यू अगर 0 होगा तो एक आइगन वैल्यू नॉन जीरो होगा, राइट। सो लेट लैम्डा बी द नॉन जीरो आइगन वैल्यू, राइट। Now note that for n cross n matrix A with rank of A is n minus is rank of A is 1, it has one non-zero eigenvalue if and only if trace of A is non-zero, ठीक है ना। अगर मैट्रिक्स का आइगन वैल्यू रैंक ऑफ ए अगर 1 होगा तो मैट्रिक्स का एक नॉन जीरो आइगन वैल्यू होगा इफ एंड ओनली मैट्रिक्स का ट्रेस नॉन जीरो होगा। सो देयरफॉर द मैट्रिक्स ए therefore the matrix A is diagonalizable if and only if trace of A which is equal to w1 minus 3w2 w1 minus 3w2 plus 2w3, I guess 2w3 is non-zero. So therefore S is equal to all such w1 w2 w3 belongs to R3 such that norm of this, if we consider this as W, norm of W is equal to 1 and W1 minus 3W2 plus 2W3, this is non-zero. Now they are asking whether this S is compact or connected. So first let's talk about its connectedness. Now note that if we write a function let phi such that R3 to R defined by phi of x y z, this is equal to x minus 2y x minus 3y plus 2z is a continuous map, right? As this is a polynomial function, so it's always continuous. Now as this is a continuous map, we know that then what I can say, then all such x y z belongs to R3 such that phi of x y z is greater than 0 is an open set in R3. Why? As this set can be written as phi inverse 0 to infinity, right? Phi inverse 0 to infinity. This is an open set. Again, in the same way, I can say that all such x, y, z belongs to R3 such that phi of x, y, z is less than 0, which is equal to phi inverse minus infinity 0 is also open in R3. Now, note that this S can be written as is equal to all such W1, all such W1, W2, W3 such that norm of this is equal to W, norm of W is equal to 1, and uh, W1 minus 3W2 plus 2W3 is greater than 0. Union all such W1, W2, W3, W belongs to R3 such that norm of W1, norm of W equal to 1 and W1 minus 2W2, W1 minus 3W2 plus 2W3 is less than 0. These are two disjoint open set in S. This is a set in open set in S. This is a open set in S, and these two open sets are disjoint in S. So S can be written as disjoint union of two open sets. Therefore, S is not connected. Although, and by Heine-Borel theorem, we know that any subset S of Rn is compact if and only if it is closed and bounded. Is compact if and only if it is closed and bounded, right? Now we know that this kind of set is not closed as any point lying any point W is satisfying norm of W is equal to 1 and W1 minus 3W2 plus 2W3 is equal to 0 is the limit point of this kind of sets. So hence my conclusion is S is neither compact nor connected, which is our option B. So option B is our. इस वीडियो में हम गेट 2025 का क्वेश्चन नंबर 23 सॉल्व करेंगे, जो क्वेश्चन पूछा गया था लीनियर अलजेब्रा से. क्वेश्चन में बोल रहा है कि let PAX denote the characteristic polynomial of the matrix A, then for which of the following matrix M the polynomial PMX minus PM inverse X is constant. So इस क्वेश्चन को आप बहुत बहुत तरीके से सॉल्व कर सकते हो. इस वन ऑफ द टेक्निक इज फॉर एवरी मैट्रिक्स M आप PMX and PM inverse X कैलकुलेट कर सकते हो उसको. Then you can subtract them, you can see that whether that is constant or not. Moreover, I am just going to show you a more general technique to solve this question. ओके, अगर M एक 2 क्रॉस 2 मैट्रिक्स है तो हमें पता है PMX is the characteristic polynomial of X. So characteristic polynomial क्या होता है हमें पता है कि for any square matrix characteristic polynomial is x square minus trace of M into X plus data of M. This is the characteristic polynomial of M, that is for any general matrix. Now this is PMX, then P M inverse X is x square minus trace of M inverse X plus date of M inverse. Okay, ठीक है ना. Now let M equal to okay. Now if we subtract PMX PM inverse X, let's simplify this. So if we do it, then I'll get X into trace of M inverse minus trace of M plus date of M minus डेट ऑफ m inverse, right? So जो question है, this question will, this polynomial have no term of x, that is it only has constant term if it vanishes. It means therefore trace of m is equal to trace of m inverse. ठीक है ना? Now I'm considering a general 2 cross 2 matrix A, B, C, D. Definitely that is invertible, as they are saying M is an invertible matrix. So if this is M, we know that M inverse, that is data AD minus BC into DA minus C minus B. This is M inverse. Now trace of M is equal to A plus D, which is equal to trace of M inverse. Trace of M inverse is A plus D divided by AD minus BC. This is the trace of M inverse. This is equal to 0. Now if we take this to our left hand side, that would become A plus D minus A plus D by AD minus BC. This is equal to 0. Now, so that becomes A plus D into AD minus BC minus 1. This is equal to 0. So that would imply A plus D, and that was date M minus 1. This is equal to 0. That would imply A plus D equal to 0 or date M equal to 1. So any matrix M which is satisfying any one of these two conditions is going to be our required answer. So first let us check for the matrix A. This is this, for this matrix A, trace of M which is equal to 8, that is not satisfying our condition, first condition. But let us calculate date of M. Date of M equal to 15 minus 14, which is 1. So date of M is satisfying this condition, so A is one of our required answer for this matrix. Trace of M is 5, not satisfying the condition. Date of M is equal to 6 minus 4, which is 2, so this is not our required answer. Trace of M is 0, so this is one of our required answer, right? So for this matrix, trace of M equal to 2, not satisfying the condition, so then we calculate that M equal to minus 15 plus 16, which is 1, so that is satisfying our condition. So option D is our correct option. So therefore the correct options are A, C and D. So that's all about our question number 23. Thank you. हेलो एवरीवन. सो इस वीडियो में हम गेट 2025 का क्वेश्चन नंबर 27 सॉल्व करेंगे, जो क्वेश्चन पूछा गया था लीनियर अलजेब्रा से. सो क्वेश्चन नंबर 27 बोल रहा है कि लेट M be a 7x7 मैट्रिक्स विद एंट्रीज इन R हैविंग द कैरेक्टरिस्टिक पॉलिनोमियल दिस, let rank of M minus I is equal to rank of M minus 2I is equal to rank of M minus 3I, where I7 is the 7x7 matrix, and if mmx is the minimal polynomial of M, then mm5 is equal to, in integer we need to calculate it. So let's get started. Let's start the solution. Okay, so the characteristic polynomial Cmx is equal to x minus 1 to the power alpha, x minus 2 to the power beta is equal to x minus 3. ठीक है ना, is whole square. Now we know that characteristic values or eigenvalues is the root of the characteristic polynomial. So इससे हम बोल सकते हैं जो 3 eigenvalue है, so algebraic multiplicity of 3 is exactly 2. ठीक है ना. तो अब है क्या निकालना है, we need to find the algebraic multiplicity of 1 and algebraic multiplicity of 2. ठीक है. Now as rank of M minus I7, this is equal to 5. So by rank nullity theorem we can calculate the nullity of m minus I7, that is 7 minus 5 by Rank-Lenity theorem. So that gives you 2. And in the same way, nullity of m minus 2i, that 7, that is again 2. Now we know that for any eigenvalue, for any eigenvalue lambda, nullity of m minus lambda I is also known as geometric multiplicity of lambda. ठीक है ना? This is also known as geometric multiplicity of lambda. Therefore हम इससे क्या बोल सकते हैं कि geometric multiplicity of the eigenvalue 1 is 2, geometric multiplicity of the eigenvalue 2 is also 2, and in the same way as you can see that rank of m minus 3i is also 5. So हम बोल सकते हैं geometric multiplicity of the eigenvalue 3 is also 2. ठीक है ना? And we also know that algebraic multiplicity of any eigenvalue lambda is always greater equal to its geometric multiplicity. ठीक है ना? अब देखो कि as M is a 7 by 7 matrix, it can have at most 7 eigenvalues, or in other words I can say that it has exactly 7 eigenvalues. इसका eigenvalue exactly 7 होगा. इसमें बोल चुका है कि 3 जो eigenvalue है इसका algebraic multiplicity 2 है. So 7 में से 2 तो 3 के रेस्पेक्ट में होगा. अगेन eigenvalue 2 has algebraic multiplicity 2 at least, so वो भी 2 होगा, and eigenvalue 1 has algebraic multiplicity 2. Now as the total eigenvalue is 7, as 3 is repeating only 2 times, तो हम बोल सकते हैं जो eigenvalue, this is for eigenvalue 2, this is for eigenvalue 3, and this is for the eigenvalue 1. अब for the eigenvalue 2 और eigenvalue 1 दोनों में से एक के लिए algebraic multiplicity 3 होगा. अब देखो वो लोग बोल रहा है कि लैम्डा अल्फा जो है दैट इज स्ट्रिक्टली ग्रेटर देन बीटा, सो दैट इज 3 एंड दैट इज 2. 3 to 5, 5 to 7. ठीक है ना? तो हम इससे क्या बोल सकते हैं कि जो algebraic multiplicity of, therefore algebraic multiplicity of 1 is 3, algebraic multiplicity of 2 is 2, and algebraic multiplicity of 3 is 2. ना हमें algebraic multiplicity मिल चुका है. अब हम लोग क्या करेंगे, इसका जॉर्डन ब्लॉक, we will find out its Jordan block and then we will calculate its minimal polynomial. ठीक है ना? Now जॉर्डन ब्लॉक का जो बेसिक जो रूल है एक बार बोल देते हैं. जॉर्डन ब्लॉक और जॉर्डन का फॉर द जॉर्डन कैनोनिकल फॉर्म, पहला जो है सम ऑफ orders of all Jordan block is equal to its algebraic multiplicity of that eigenvalue ठीक है ना? एंड सेकेंड जो है number of Jordan blocks is equal to the geometric multiplicity of the eigenvalue. ठीक है ना? So as the geometric multiplicity of each eigenvalue is 2, so हम बोल सकते हैं 3 के लिए जो जॉर्डन ब्लॉक होगा, number of Jordan block is 2 for the eigenvalue. 3 के लिए number of Jordan block is 2, eigenvalue 2 के लिए number of Jordan block is 2, 1 के लिए number of Jordan block is 2, and sum of all Jordan block is equal to algebraic multiplicity. Now note that as जो 3 eigenvalue है इसका number of Jordan block 2 है और टोटल हमें 2 जॉर्डन ब्लॉक चाहिए, सो ईच ऑर्डर ऑफ ईच जॉर्डन ब्लॉक इज 1. अगेन फॉर द आइगन वैल्यू 2 नंबर ऑफ जॉर्डन ब्लॉक इज 2 एंड हमें 2 जॉर्डन ब्लॉक चाहिए, तो जॉर्डन ऑर्डर ऑफ ईच जॉर्डन ब्लॉक इज अगेन 1. एंड जो आइगन वैल्यू 3 है, इसका जो एल्जेब्रिक मल्टीप्लिसिटी 3 है, सो सम ऑफ ऑर्डर्स ऑफ ऑल जॉर्डन ब्लॉक इज 3 एंड हमें 2 जॉर्डन ब्लॉक चाहिए, सो एक जॉर्डन ब्लॉक का ऑर्डर होगा मैक्सिमम 2 और एक जॉर्डन ब्लॉक का ऑर्डर होगा 1. नाउ सो मिनिमल पॉलिनोमियल क्या होता है? मिनिमल पॉलिनोमियल में जो जॉर्डन ब्लॉक ईच जॉर्डन ब्लॉक का जो मैक्सिमम पावर होता है वो आता है. सो द मिनिमल पॉलिनोमियल, इसका 3 जो आइगन वैल्यू है, इसका मैक्सिमम ऑर्डर 1 हो, सो 1. सो 2 जो आइगन वैल्यू है, इसका मैक्सिमम ऑर्डर 1 हुआ है, सो वो भी that would be x minus 2, and one eigenvalue, the maximum order of the eigenvalue 1 is 2, so that's why that would be x minus 1 is whole square. So this is the minimal polynomial of that matrix. Now हमें क्या, what we need to calculate? We need to calculate minimal polynomial at the point minimum mm5. So let's calculate it. mm5, so that is equal to 5 minus 3, 5 minus 2 and 5 minus 1 whole square. So that is 2 multiplied by 3 multiplied by 4 square. So which is equal to 96. Now 96 as is an integer, so हमें और कुछ करना होगा नहीं. So answer to the question is 96. So thank you everyone. सो इस वीडियो में हम गेट 2025 का क्वेश्चन नंबर 31 डिस्कस करेंगे, जो क्वेश्चन पूछा गया था लीनियर अलजेब्रा से. क्वेश्चन नंबर 31 में बोल रहा है कि लेट W be the vector space of over R consisting of all bounded real solutions. So that is very important, bounded real solution of the differential equation d4y dx4 plus 2 d2y dx2 plus y is equal to 0. Then dimension of W in integer, हमें वो we need to find out the dimension of W. Now my point is that we know that to solve this kind of differential equation, first we need to calculate its characteristic equation. So the characteristic equation is m4 plus 2m square plus 1 is equal to 0, right? This is a basic mathematics. Now from this we need to calculate the value of m, that is m square plus 1, which whole squared is equal to 0, and that gives you the value of m is equal to plus minus i. ठीक है ना? Now if the value of m is plus minus I, we know the general solution of this kind of differential equation, y equal to a plus bx cos x plus c plus dx sin x. Now they are saying that W consists all the bounded solutions. Now if any one of b and d is non-zero and sine and cos is bounded quantity, and note that the value of sine and cos is non-zero on uncountably many points, right? Sine और cos का जो zero है, that is countable set. So if any one of b and d is non-zero, as x is an unbounded set, unbounded function, so that solution would be unbounded. So to get the bounded solution, both b is equal to 0 and d is equal to 0. You can intuitively feel that. So therefore our required solution y equal to a cos x plus c sin x. So dimension of this W is 2, as it needs 2 non-zero scalar to write down any solution. We know that dimension of a vector space is the least number of non-zero scalars required to write down an arbitrary vector. So this is dimension of W is 2. So answer to the question number 31 is 2. So thank you. सो इस वीडियो में हम गेट 2025 का क्वेश्चन नंबर 31 डिस्कस करेंगे, जो क्वेश्चन पूछा गया था लीनियर अलजेब्रा से. क्वेश्चन नंबर 31 में बोल रहा है कि लेट W be the vector space of over R consisting of all bounded real solutions. So that is very important, bounded real solution of the differential equation d4y dx4 plus 2 d2y dx2 plus y is equal to 0. Then dimension of W in integer हमें वो we need to find out the dimension of W. Now my point is that we know that to solve this kind of differential equation, first we need to calculate its characteristic equation. So the characteristic equation is m4 plus 2m square plus 1 is equal to 0, right? This is a basic mathematics. Now from this we need to calculate the value of m, that is m square plus 1 which whole squared is equal to 0, and that gives you the value of m is equal to plus minus i. ठीक है ना? Now if the value of m is plus minus I, we know the general solution of this kind of differential equation, y equal to a plus bx cos x plus c plus dx sin x. Now uh, they are saying that W consists all the bounded solutions. Now if any one of b and d is non-zero and sine and cos is bounded quantity, and note that the value of sine and cos is non-zero on uncountably many points, right? Sine और cos का जो zero है, that is countable set. So if any one of b and d is non-zero, as x is an unbounded set, unbounded function, so that solution would be unbounded. So to get the bounded solution, both b is equal to 0 and d is equal to 0. You can intuitively feel that. So therefore our required solution y equal to a cos x plus c sin x. So dimension of this W is 2, as it needs two non-zero scalar to write down any solution. We know that dimension of a vector space is the least number of non-zero scalars required to write down an arbitrary vector. So this is dimension of W is 2. So answer to the question number 31 is 2. Thank you. सो इस वीडियो में हम गेट 2025 का क्वेश्चन नंबर 36 डिस्कस करेंगे, जो क्वेश्चन था कॉम्बिनेशन ऑफ न्यूमेरिकल एनालिसिस एंड थोड़ा बहुत लीनियर अलजेब्रा का. सो क्वेश्चन बोल रहा है कि कंसीडर द लीनियर सिस्टम ax इक्वल टू b वेयर a इक्वल टू aij वेयर aij नॉन जीरो फॉर ऑल I is a matrix with real entries, and D is this matrix, then the inverse A is given by this, the inverse B is given by this. So this statement 1 is the approximation of x after one iteration of Jacobi's scheme with initial vector x0 is x1 is equal to this, and there exists an initial vector x0 for which the Jacobic iterative scheme diverges. So which of the following is correct? That is what we need to check. So let's start the solution. First, what I am doing, I'm just writing the Jacobi's iteration formula. We all know that in case of numerical analysis हमें तो formula याद रखना ही होगा. So Jacobi iteration formula is x, we know that x k plus 1, this is equal to j x0 plus d inverse b. सही है ना? So हमें क्या बोल रहा है कि x0 अगर होगा तो x1 whether x1 is this vector or not, where j equal to I minus d inverse a, I minus d inverse a. Okay, so पहले let's calculate I minus d inverse a. I is equal to 1 0 0 0 1 0 0 0 1. This is I minus d inverse a is given by this matrix 1 1 negative 2 3 1 2 1 1 1. Okay, so let's calculate I minus d inverse b. So that is equal to 0 minus 1 2 minus 3 0 negative 2 minus 1 0. So that is our J. Now so x, in place of this, if I put k equal to 0, x1 equal to J x0 plus D inverse B, right? So we have the matrix J. So J is equal to 0, minus 1, 2, minus 3, 0, negative 2, negative 1, negative 1, 0. That is J. x0 is the 1 1 1 1 1 1, and D inverse B is 5 minus 1 minus 1. Sorry, D inverse B is 4 4 1. 4 4 1. So if you multiply this, you would get this is equal to 1 minus 5 minus 2 plus 4 4 1. So which is equal to 5 minus 1 minus 1. So let us check our x1 is 5 minus 1 minus 1. So s1 statement is for sure true. So let's discuss about s2. S2 is saying that there exists an initial vector x0 for which Jacobi iterative scheme diverges. So we know that the basic result that Jacobi, let me write down the basic theorem of Jacobi iterative scheme, that Jacobi iteration converges for all initial vector x0 कब, if and only if rho of j is less than 1, where rho of j is the largest absolute value of the eigenvector of j, largest absolute value of the eigenvectors of j. सही है ना? तो हमें इस थ्योरम से क्या पता चलता है? जैकोबीज इटरेटिव स्कीम कन्वर्जेस फॉर ऑल x0 जब इसका जो लार्जेस्ट आइगन वैल्यू का एब्सोल्यूट वैल्यू, मतलब एब्सोल्यूट आइगन वैल्यू का जो लार्जेस्ट एब्सोल्यूट वैल्यू होगा वो that is less than 1. So now what we have to do, we just need to calculate the eigenvalues of j. Okay, so for the purpose what हमें पहले क्या करना होगा, जो j मैट्रिक्स का कैरेक्टरिस्टिक पॉलिनोमियल है, let's find that j minus xi, det of j minus xi. So that is det of minus x minus 1 2 minus 3 minus lambda minus x, sorry, minus x minus 2 minus 1 minus 1 minus x. So this the determinant of this matrix. If you break this, you would get this is equal to x cube minus 3x minus 4. Okay, so therefore the characteristic polynomial chx is x cube minus 3x minus 4. Now if we want to calculate the root of this polynomial, that is not an easy task. So but what I am doing, I am just calculating the value of the characteristic polynomial at x equal to 2. So the value of the characteristic polynomial, that is 2 cube minus 3 into 2 minus 4, which is negative 2, and the value of the characteristic polynomial ch at the point 3, which is 3 cube minus this, so that is 14. So हम क्या बोल सकते हैं, c characteristic polynomial at the point 2 is less than 0, where the value of the characteristic polynomial at the point 3 is greater than 0. Then by intermediate value property, I can say there exists a c belongs to 2 3 such that ch at the point c is 0. So हमें एक ऐसा आइगन वैल्यू मिलेगा जिसका value 2 say that would be bigger than 2 and lesser than 3. So from that what I can say that जे इसका एक ऐसा आइगन वैल्यू आएगा जिसका वैल्यू 1 से ज्यादा होगा. So अगर if we get an eigen value which is more than 1, so by contrapositive statement or by the converse statement I can say that there exists an initial vector x0 for which the Jacobi scheme diverges. So both 1 and 2 is true. So thank you everyone. इस वीडियो में हम गेट 2025 का क्वेश्चन नंबर 48 डिस्कस करेंगे जो क्वेश्चन पूछा गया था लीनियर अलजेब्रा से. So question number 48 over R of all 2 cross 2 matrices with entries in R, consider the linear transformation T such that M2R to M2R defined by Tx is equal to AXB, where A is this matrix, B is this matrix. If P is the representation of T with the standard basis of M2R, which of the following are true? So हमें इस क्वेश्चन सॉल्व करने के लिए हमें पहला एक रिजल्ट चाहिए जो if Tx such that M2R to M2R defined by Tx is equal to AXB. So हमें T को लिख सकते हैं T is equal to Kronecker product of B transpose A. ठीक है ना. तो हमें तो Kronecker product पता है नहीं, तो एक्चुअली वी डोंट नीड दैट Kronecker product. हमें और एक रिजल्ट चाहिए कि the matrix representation if T, this is the matrix representation of T, then eigenvalues of this matrix or this is the or the eigenvalue of the linear transformation T are product of or precisely the product of the eigenvalues of A and B. So जो T मैट्रिक्स होगा और जी लिनियर ट्रांसफॉर्मेशन T का आइगन वैल्यू क्या होगा? अगर A का मैट्रिक्स है A1 A2, A का आइगन वैल्यू है A1 A2, B का आइगन वैल्यू है B1 B2, so A1 B1 A1 B2 A2 B1 A2 B2, so these are the आइगन वैल्यूज ऑफ T. बहुत सिंपल. so शुरू करते हैं. now the A matrix is 1 minus 2 1 4. So if we find out the characteristic polynomial of A, the characteristic polynomial of A x square minus trace A x plus det A. This is the characteristic polynomial of A. This is equal to 0. So x square minus trace is 5x plus det is 4 minus 2 minus 2, so 6. This is equal to 0. So x square minus 3x minus 2x plus 6. This is equal to 0. ठीक है ना. तो हम बोल सकते हैं दिस इज इक्वल टू इफ वी टेक x कॉमन, सो दैट गिव्स यू x minus 3 minus 2 common, that's again gives you x minus 3, so x equal to 2 3. So these are the eigenvalues of A. Now B matrix is B is equal to 6 5 minus 2 minus 1, 6 5 minus 2 minus 1. So therefore the characteristic polynomial of B is equal to x square minus trace B x plus det B. This is equal to 0. So that gives you x square minus trace B is 5. So 5x plus det B minus 6 minus of minus, so 10. So that gives you 4, which is equal to 0. So this is equal to x square minus 4x minus x plus 4. This is equal to 0. So x is equal to 1 4. So these are the eigenvalues of B. So therefore eigenvalues of T are 2 into 1 2 into 1 2 into 4 3 into 1, 3 into 4, so which is equal to 2, 8, 3, 12. So these are the eigenvalues of T. So now let us discuss the question. So options, so 2, 8, 3, 12, right? So I'm just writing somewhere 2, 8, 3, 12. So पहला जो क्वेश्चन है T is invertible. We know that a matrix or a linear transformation T is invertible if and only if 0 is not the eigenvalue of that linear transformation. So as 0 is not the eigenvalue of this linear transformation, so A is true. ठीक है ना? Now moving on to the option B. So trace, we know that trace of the matrix, trace of P is the sum of all eigenvalues, sum of all eigenvalues. So that is equal to 12 plus 8, 20 plus 8, 23 plus 2, 25. So 25 is the sum of all eigenvalues. Now then वो लोग पूछ रहा है कि I'm just erasing this part. Rank of p square minus 4i. So first we will calculate the eigenvalues of p square minus 4i. Eigenvalues of p square minus 4i. So p square minus 4i का eigenvalue क्या होता है? p का eigenvalue 2 है. So 2 square minus 4, 8 square minus 4, 3 square minus 4 and 12 square minus 4. Now so इसमें हम देख सकते हैं कि this is equal to 0, this is equal to 60, 5, 140. So these are the eigenvalues of p square minus 4i. Now as it contains, now note that here it contains 0 as an eigenvalue. So हम बोल सकते हैं कि date of p square minus 4i is equal to 0. अगर डेट 0 होगा सो इस मैट्रिक्स का तो रैंक कभी भी 4 नहीं आएगा क्योंकि रैंक 4 आने के लिए डेट नॉन जीरो होना होता है. सो दिस इज रॉन्ग and nullity of this is equal to 0. Now p minus 2i का हम लोग आइगन वैल्यू निकालते हैं. So p minus 2i का आइगन वैल्यू होगा 2 minus 2, 2 minus, sorry, 8 minus 2, 3 minus 2 and 12 minus 2. So these are the eigenvalues of p minus 2i which is equal to 0, 6, 1, 10. So now as p minus 2i का भी eigenvalue 0 है एक, so हम बोल सकते हैं date of p minus 2i is equal to 0. So date अगर 0 होगा तो हम बोल सकते हैं rank of p minus 2i is definitely less equals to 3. Now by rank nullity theorem हम बोल सकते हैं nullity greater equal to 1. So this is also wrong. So that's all about our question number 848. Thank you everyone. Okay, इस वीडियो में हम गेट 2025 का क्वेश्चन नंबर 62 डिस्कस करेंगे जो क्वेश्चन लीनियर अलजेब्रा से पूछा गया था and that was the last question जो linear algebra से पूछा गया था. So question number 62 क्या बोल रहा है? Let x belongs to R3, consider the quadratic form. हमें एक quadratic form दिया हुआ है and M be the symmetric matrix associated with this quadratic form QX with respect to standard basis of R3. Why is this? So हमें इसका लिमिट कैलकुलेट करना है. So पहले हम एक बार quadratic form लिख लेते हैं. QX equal to 2x1 square plus 2x2 square plus 3x3 square plus 4x1 x2 plus 2x1 x3 plus 2x2 x3. So this is the quadratic form. So if we calculate the matrix M associated with this quadratic form, M क्या होगा? M एक 3x3 ऑर्डर का मैट्रिक्स होगा जिसके डायगोनल में आएगा 2, 2, 3. ठीक है ना? इस साइड में आएगा 2, इस साइड में भी आएगा 2, इसमें 1, इसमें 1, इसमें 1, this is again 1. So this is the matrix M. Now if we calculate, first what I'll do, I'll calculate the eigenvalues of M. So if you calculate the eigenvalues of M, I already have calculated that. Eigenvalues of M are, M का eigenvalue आएगा 5, 2 and 0. 0 eigenvalue आएगा. It is very much clear that first row, first column and second column is identical. And if you check the other two eigenvalues, that are 5 and 2. Okay, I am not wasting my time by calculating the eigenvalues. So अगर m का eigenvalue 5, 2 और 0 आएगा, so therefore eigenvalues of m plus I are 5 plus 1 6, 2 plus 1 3, and 0 plus 1 is 1. Now interesting point is just as m is a symmetric matrix and I is a symmetric matrix, if you calculate m plus I transpose, that gives you m transpose plus I transpose, which is again m plus I. So m plus I is also symmetric matrix. Now there is a very beautiful result about a real symmetric matrix, that a real symmetric matrix is always orthogonally diagonalizable. Real symmetric matrix is always orthogonally diagonalizable. Okay, a real symmetric matrix is always orthogonally diagonalizable. तो हमें क्या मिलेगा? We can consider an orthonormal basis v1, v2, v3 of R3, where each vi is an eigenvector, right? This is the definition of a matrix which is orthogonally diagonalizable. I am considering v1 the eigenvector with respect to the eigenvalue 5 is 6, v2 is the eigenvector with respect to the eigenvalue 3, and v3 is the eigenvector with respect to eigenvalue 1. So therefore हम क्या बोल सकते हैं? I can say m plus I of v1 equal to 6 v1, m plus I of v2 is equal to 3 v2, and m plus I of v3 is equal to 3 v3. सही है? अब they are saying y is any non-zero vector of R3. So any non-zero vector of R3 can be written as c1 v1 plus c2 v2 plus c3 v3. ठीक है ना? अब then let's calculate m plus I is whole to the power n of y. So m plus I is whole to the power n into c1 v1 plus c2 v2 प्लस c3 v3. ठीक है ना? तो हम इससे क्या बोल सकते हैं? c1 m plus I is whole to the power n of v1 plus c2 m plus I is whole to the power n of v2 plus c3 m plus I is whole to the power n of v3. So हम इससे बोल सकते हैं c1 that would be 6 to the power n of v1 plus c2 3 to the power n of v2 plus c3 v3 v3. सही है ना? So now if we calculate y transpose, m plus I is whole to the power n of y. So वो क्या आएगा? c1 v1 plus c2 v2 plus c3 v3 is whole transpose of 6 to the power n c1 v1 plus 3 to the power n c2 v2 plus c3 v3. Now हमें पता है ट्रांसपोज को हम लिख सकते हैं c1 v1 ट्रांसपोज प्लस c2 v2 ट्रांसपोज प्लस c3 v3 ट्रांसपोज of 6 to the power n c1 v1 plus 3 to the power n c2 v2 plus c3 v3. अब क्योंकि v1 v2 v3 एक ऑर्थोनॉर्मल बेसिस है, हम बोल सकते हैं v1 ट्रांसपोज v1 दैट इज 1 एंड v1 ट्रांसपोज बोल सकते vi ट्रांसपोज vj दैट इज 1 if I equal to j and 0 if I not equal to j. ठीक है ना? सो इफ वी मल्टीप्लाई दिस, पहले हम जब इसको इससे मल्टीप्लाई करेंगे हमें क्या मिलेगा, 6 to the power n c1 स्क्वायर, इससे मल्टीप्लाई करेंगे तो 0, इससे मल्टीप्लाई करेंगे तो 0, फिर आएगा 3 to the power n c2 square, then c3 square. Now if I take 6 to the power n common, so I would have c1 square plus c2 square, 3 by 6 is whole to the power n plus c3 square over 6 to the power n, right? So this is the value of y transpose m plus I is whole to the power n of n y. Now there an is given by y transpose m plus I is whole to the power n plus 1 y over y transpose m plus I is whole to the power n y. So I have 6 to the power n plus 1 c1 square plus c2, 3 by 6 is whole to the power n plus 1 plus c3 square by 6 to the power n divided by n plus 1, sorry, 6 to the power n c1 square plus c2 square, 3 by 6 is whole to the power n plus c3 square by 6 to the power n. So if I take, now I can cancel this, I would have 6. Now if I take the limit, so if I take the limit, so that becomes 6, this remains c1 square, this is 0 and this is 0, by this is c1 square I have, this is 0, this is 0, so cancelling c1 square into c1 square, this limit is 6. So as n tends to infinity, so limit an is 6, which is our required answer. So answer is 6. So that's all about our question number 62. Thank you.